Alrighty, the last part of the 5.2 notes include graphing proportional relationships. So this is the first time this semester that we're going to be working with a graph. And so this might be the first time ever that you're working with a graph. And so the objective for this lesson is that by the end of this lesson, you will be able to graph a ratio table of x and y coordinates. And then the essential question: what does a proportional relationship look like on a coordinate plane? So this does tie into what we're working in now. We're working with proportional relationships. So that's one ratio that's equal to another ratio. And so we're going to see, what does that actually look like on a graph, on an XY graph? So first, let's begin by taking a look at this that we've got here. We're being asked to graph the values from the ratio table. And we have time in seconds as the x values, and then height in meters as the y values. Now, it's important to note, it's important to recognize which of the planes is the x value and which of the planes are the y values. So let's put that as a question here, because that might be something you guys don't know yet. So, which direction do the x values travel? What about the y values? So, and to answer that question for you, x travels horizontally. And so just as a reminder, the horizon, or where the sun comes up from, goes from left to right. So horizontally, you can remember as the horizon, left to right, that's the x values. And then the y values, the y value travels vertically, which means up and down. So that means that my x values of time, those are going to travel horizontally on my graph. As I can see here, they're traveling left to right, and then my height travels vertically or up and down. Now, I'm being asked to graph these values from the ratio table. And so I'm going to take my x value, this 3, and I'm going to start at 0. I'm going to go 3 to the right, 1, 2, 3, and that's my x value. But I also need to go up 2 on my y value. So I'm going to go 3, then up to 1, 2, and then so my point is going to be right here, 3, 2. 3 representing the x value, and then 2 representing the y value. And then I would continue to graph the remainder of the spots. We've got 6, 4, so 6 to the right, up 4. And then my third value, 9, so 6, 4. And then I've got 9, 6, so here's 9, here's 6, and then we meet up over here. So this is my 9, 6 value. And then lastly, my 12, 8. So 12 here at the very end, 8 being over here. 12, 8 is this point right here. And then you should notice that you can actually make a straight line out of these values here. So if I start here, and then I can make a straight line out here. And so this is a graph, this height-time graph, height versus time, is a representation of something traveling upwards as the time progresses. And we can see that they're doing it constantly because we're getting a solid line. And because we're getting a solid line, we would call that we would say that the graph shows a constant rate of change. That solid line is telling us that the speed of whatever is traveling upward is not changing, it's being consistent. If it was changing, we'd see something like this, where it would increase, it'd go up a lot faster, or maybe a little slower, maybe go down a bit, but it's just continuously going up at the same rate. What rate is that? We'll figure that out in just a second. So you can use the constant rate of change to show that the graph passes through the origin, because when we created that line, we started at this point here, which is 0, 0. And that 0, 0 point, that's called the origin. That's like the beginning position of any graph. And even if the graph had this 4 coordinate planes, right here, smack dab in the center, would still be considered the origin. So the origin is always going to be at point 0, 0. 0 to the right on the x and 0 up or down on the y. So it's at the very beginning point. The graph of every proportional relationship, this is important that we talk about the origin because the graph of every proportional relationship is a line through the origin. So what does a proportional relationship look like on a graph? It's a straight line, and it passes through the origin. So let's go ahead and make a note of that. A proportional relationship on a graph is a straight line, so no curves, and then the straight line doesn't change, so just one straight line that also passes through the origin. So those are our two requirements, is that a proportional relationship on an XY graph is a straight line. Let me put that in a different color. Straight line and passes through the origin. Those are our two requirements for a proportional relationship on a graph. And that's going to be important because if we move on through here, you may need to pause the video to take down that note. But as we move on, we have some examples where we're going to be asked to determine whether the two quantities are proportional by plotting the points on the graph. So we're going to have to put these points on the graph and then just by looking at it, determine whether it's proportional or not. So let's go ahead and graph these XY points. I've got 2, 6, 2, 6. So I'm going to start at 2 and then go up 6. And so I'm going to place 1 point here. This is my 2, 6 point. And then the next point, 4, 8. So I'm going to go 4 up to 8, puts me right here. And then 6, 10 will put me here. And then if I were to make a straight line out of all these, as straight as I can get it, then this is what my line would look like on my XY graph. Now, this is a straight line, and that straight line is not changing at all through any point of the plots we were given. But the thing about this straight line is that it doesn't pass through the origin. It doesn't pass through this point here, 0, 0. And so because it does not pass through the point here, we would say that it is not proportional. Because a proportional line or a proportional relationship has to travel through the origin. It has to travel through 0, 0, 0. So let's check the other one and check the other graph here and see how that one does, how that one compares. We're going to start at 1 for x and then go up 2. And then we're going to go 2, 4, and then 3, 6. I'm going to plot those points. And then I'm going to trace them down into a straight line. And I can see that on this one we have a straight line, and it indeed does pass through the origin when I made that straight line. When I connected those points, it did pass through the origin, so we would say yes, there is a proportional relationship here because it's a straight line and it passes through the origin. So it's as simple as that. It's about just plotting the points and then checking to see if they have that those two requirements. If it's a straight line and it passes through the origin. Let's try another one. So we've got x is 1, where y is 3. So 1 up 3. And then we've got our next point is 2 to 4. So let's see, we got 2, 4, and then 3, 5, and 4, 6. And you can see we've got our points here. And if we straight these down to a straight line, then you can see that even though it's a straight line, does not pass through the origin, so we would say no, not proportional. And we can also check the values in the ratio table. So for example, if I wanted to compare 1/3 and 2/4, or 1/3 and 2/4, and check if they are equal to each other, I could take their cross products. 1 times 4, it's going to be 4. And is that equal to 3 times 2? Which, no, it's not. So therefore, that's another way that we can confirm that this is not a proportional relationship. Now this last one, we've got some decimals involved here, but hopefully that does not confuse you anymore now at this point in the semester. We're going to start with our x value, which is at 1. And then we're going to go up half of a point. So we're just going to go up to here. Not all the way at 1, just half. And then for 3, we're going to go here 3, and then up 1.5, so 1.5. We're going to go up to 5, and we're going to go up 2.5. And then we're going to go to 7 and go to 3.5. And then now we need to trace these values. So from here down through all of these values. And when we do that, you can see that once we trace those values, we don't have to confirm that they are proportional by comparing any of these values. We can just look at the graph after we plotted it and say that, yes, it is proportional because it's a straight line and it passes through the origin. If we trace that line back, it passes all the way through 0, 0, the origin. And so we would say that, yes, it is proportional indeed. Okay, so the very last thing that's left is to interpret the graph of a proportional relationship. So actually understanding what each point means. So here we've got this graph. It's the Curiosity rover at top speed, and it says the graph shows the distance traveled by the Mars rover Curiosity is proportional to the time traveled. And we can tell it's proportional because it's a straight line and it passes through the origin. Interpret each plotted point in the graph. So we need to determine what does each point mean in the graph. So 0, 0. The rover travels 0 inches in 0 seconds. So at this point, the rover has not moved at all. We haven't started the rover because 0 seconds have passed by, meaning that we haven't started counting time. And if we haven't started counting time, that means we also haven't started measuring distance. So this is just the rover is in place, but we haven't started measuring anything just yet. But now at the second point of 1, 1.5 or 1.5, we would say that the rover travels 1.5 inches in 1 second. You got to keep in mind that this first value is the x value, and the x-axis is measured in time. So that 1 represents 1 second, which is why we're going to put it here in this blank, because that's talking about the seconds that have passed by. Whereas the second value is the y value, which is our distance. And so when it says the rover travels blank inches, we have to refer that to that on the y-axis, which is our distance, and say that it travels 1.5 inches. And then lastly, the 3, 4.5, the rover travels 4.5 inches in 3 seconds because the relationship is proportional. You can also use this point to find the unit rate, or you could use any point to find the unit rate. And so that's the last thing that I'm going to have you do on your own, is that you're going to use any of the points given except for 0, 0, because we haven't started measuring anything at that point. You're going to use either one of the 2 points given to determine the unit rate of the Curiosity rover and tell me how much it's traveling, how many inches it's traveling for every second. And then don't forget to do your summary at the end. And this you might summarize that you learned how to properly graph coordinate points, or you might summarize that you learned that a proportional relationship is a straight line and goes through the origin. On a graph, you might have learned that the origin is represented by 0, 0. So at the very center of the graph. So just as long as you give me a full sentence or two sentences, then I can make sure to also give you full credit.